So we've made the circuit connection for the AC balancing. This is the AC source and it has been connected with the these two terminals in the circuit. M, which was shorted initially, is now connected to this resistance bank M, and we have changed the selector switch of the null detector to the AC position, and the range is still at 20 milliampere. All the other parts of the circuit remains the same. Currently the capacitor is connected to 0.1 microfarad. Let's start with. We will not disturb the DC balance which has been obtained over here. It will remain constant throughout the experiment. We'll just make all these knobs at 0 and we will now find out the AC balancing point. So it's decreasing, it's decreasing, it's decreasing, it's decreasing. Change this 20 milliampere range to 200 microampere range for a more sensitive value. So it's still decreasing, 88.9, it's 80.5. It's increased to 83.6. So the minimum value is obtained at 600 ohms for a reading of 80.3 in the microammeter. AC balancing is thus obtained. So now we will calculate what is the value of the unknown inductance L1 from this value. After calculation, the value of the L1 comes out to be 13 millihenry. We will now change the value of the capacitor and try to achieve the same reading. Now let's make it at 0.3 microfarad. Okay, so now let's again start with this. So it was 53 over here and it's coming to 55 over here. So we'll just keep it at 100 ohms and try to change it with this 10 ohm resistance knob. It's changing. Let's make it a bit more sensitive and change the range to 20 microampere. So it's increasing. $95.1, 95.2, it's increasing. So this is the minimum value. So we are getting 110 ohms for 0.3 microfarad, and we will now make the calculation to see what is the value of L. After calculation, L comes out to be 10.3 millihenry. We have now changed the value of the capacitance to 0.2 microfarad, and the knob is current. The selector switch is currently at 20 milliampere. So if we start changing it, let's change it to a more sensitive value. Okay, so it's 179 currently. It's 107. It's decreasing. It's 83.4. It's increased. So this is the minimum value we are getting for 100 ohms selector knob. So let us keep it at 200 ohms and try to achieve the same value of 83.5 with this 10 ohms selector knob. So the value is decreasing. $84.1, 83.5, 83.4, 83.3, 83.5. So the minimum is coming at this for 90 ohms. So the total value of M is 290 ohms. And if we calculate the value of L by putting the value of 290 ohms in place of small m in the formula as given in the manual, we get the value as 13.6 millihenry. So now the capacitance value has been changed to 0.4 microfarad and the selector switch is at 20 milliampere. So we will just change it. It's coming at 0.49. It is increased to 0.6, so we will keep this at this one. For 100 ohms we are getting the minimum value, so we'll keep this as 0 and try to achieve a value which is less than that obtained by 100 ohms. Still decreasing. Still decreasing. Okay, so it is coming at 100 ohms. The minimum value is coming at 100 ohms because if we increase above this, it is increasing. The value is increasing, right? So the minimum value is 100 ohms for 0.4 microfarad. And if we calculate the value of L, it is coming to be 12 millihenry. Similarly, you can also check for 0.5 microfarad what the value of L is coming. So capacitor is now at 0.5 microfarad and the selector switch is at 20 milliampere. So if we are changing with this 100 ohm knob, 0.6. Now it's increasing, so we will not change it with 100 ohms. We'll keep it at 0 and start changing with this 10 ohm knob. It's 1.5, 1.4, 0.0. It's decreasing. It's keeping on decreasing. Six 1.59. So if you see no change, then it means you have to just go back a few steps and you have to change this range to make it more sensitive to 200 microampere. Now if you change, you will see the difference. Okay, so it's decreasing 1.109, it's decreasing still 104.5, 103.3, still decreasing, 103.2. It has increased to 104.4. So this is the minimum point where we are getting the that is the value where we are getting the minimum null detector value. So the M comes out to be 80 ohms in this case, and if we calculate the value of the unknown inductance L using 80 ohms as M and 0.5 microfarad as the capacitance value, it comes out to be 13 millihenry. You can repeat the same experiment by using L2 as the unknown inductance, and then you have to set the DC balancing first and then move on to the AC balance. So this concludes our experiment for Anderson bridge.
Please subscribe to our channel for more such videos. Thank you for watching.